Millions visit the Grand Canyon each year, believing they understand what lies there. Entire areas quietly closed, discoveries denied, decisions buried in federal files. From mysterious claims to disasters that reshaped national policy, the canyon holds far more than ancient rock. What exactly happened in the places visitors were never meant to question, under a name that did not belong? Visitors arriving at the South Rim are usually given a simple frame for the Grand Canyon. The place is introduced as a national park, a geological record, and a landscape arranged for public viewing through roads, overlooks, lodges, and trails. That frame is accurate in part, but it is incomplete in a measurable way. Grand Canyon National Park formally recognizes 11 traditionally associated tribes, and park records document 3,391 ancestral sites within park boundaries, along with hundreds of locations showing historic native use. The official landscape has never been empty ground waiting for administration. It has long been inhabited, named, used, and contested. One of the clearest places to see the gap between public presentation and administrative history is a stop on the Bright Angel Trail, now called Havasupai Gardens. For decades, most visitors knew it as Indian Garden, a name printed on maps, signs, trail guides, and trip plans. In November 2022, the National Park Service formally changed the name after request from the Havasupai tribe. The Park Service stated that the place was originally called Ha'agyo and acknowledged that the agency had instituted policies that forced Havasupai people from the area. The change did not create a new history. It corrected a public label that had outlasted the people who were removed from it. That site was not a minor camp or an occasional stopping point. NPS Historical Material describes Havasupai Gardens as the location of an ancient agricultural settlement. Water from Garden Creek supported farming there long before park boundaries and visitor infrastructure gave the area a new administrative identity. Later tourist development obscured that older use. NPS records note that Ralph Cameron dammed Garden Creek in 1903 to irrigate a garden and orchard, and established a tent camp for tourists. By the time the park took legal possession of the area in 1927, the site had already been converted in public imagination from a lived native place into a service point inside a tourism corridor. The broader legal setting around that change is also documented. An official NPS article, published in 2024, states that the Havasupai were forced onto a reservation in 1880 and that its size was sharply reduced in 1882 to 518.6 acres. That acreage is striking not because it is symbolic, but because it shows how narrow the recognized space became compared with the tribe's long connection to the canyon and surrounding plateaus. The same article notes that, before the Grand Canyon became a national park, Havasupai people spent summers farming plateaus that now fall within park boundaries. In present visitor language, those areas appear as scenic and recreational terrain. In the agency's own later historical writing, they are described as homelands from which people were compressed and then managed. The well-documented case at the center of this history is the removal of Captain Billy Burrow, also referred to in some sources as Captain Burrow. He was the last Havasupai resident at Ha'agyo. The Park Service states that he was forcibly removed in 1928. Grand Canyon Trust summaries and later NPS materials describe him as the final Havasupai holdout in the inner canyon at that location. This case matters because it is direct, named, and attached to a place still used by large numbers of hikers. It was not an abstract displacement somewhere beyond the trail system. It happened at a spring and garden area that remains one of the best-known rest points below the South Rim. The language around that removal has changed over time, and that change is revealing in itself. Earlier generations of interpretation normalized the name Indian Garden and largely detached it from the removal history. Current NPS language is more explicit. Superintendent Ed Keeble said in the 2022 renaming announcement that the Havasupai people had actively occupied the area since time immemorial and that the park had forcibly removed them. Chairman Thomas C. Ugis said that many hikers passed through the site each year while remaining largely unaware of that history. What had long been treated as a neutral trail name was later described in official statements as the public residue of a forced displacement. The record does not end in 1928. A second layer of administrative control took shape on the South Rim in Supai Camp. According to NPS planning documents, the Park Service built residences there in the 1930s and relocated Havasupai people who had been living at Indian Garden and around Grand Canyon Village. Another official NPS article states that in 1955, the agency told Havasupai individuals not employed by the Park Service to leave Supai Camp, after which park management and concessionaires began terminating many Havasupai workers and demolishing the remaining homes. Read plainly, the sequence is not difficult to follow. Removal from one lived area was followed by supervised residence in another, then by further narrowing tied to employment status and administrative convenience. This is where the title of the canyon and the paper record begin to separate. Public interpretation often suggests a landscape preserved from human interference or a wilderness saved from misuse. Yet the park's own historical material says that when Grand Canyon National Park was established in 1919, indigenous inhabitants had been killed or removed. Recent NPS interpretation also says the park is working to center native perspectives and first voice interpretation at places such as Desert View. That effort is significant, but it also confirms that earlier interpretation had not done so. A place described for generations as a national treasure was also being described in newer official language as ancestral homeland from which living communities had been displaced. The canyon's public names, buildings, and visitor routes preserve that older framing in quiet ways. Hopi House, Bright Angel, Hermit, Desert View, and Grand Canyon Village all carry layered histories of tourism, commercial design, and selective storytelling. NPS interpretive material now notes that native artists, workers, and residents were central to the park's development, and that places once presented mainly as scenic stations or rustic heritage sites were also native spaces shaped by labor, residence, and memory. The revision is visible, but it is partial. A renamed trail stop cannot by itself alter the fact that the older label remained normal for decades, while the circumstances behind it stayed peripheral for most visitors. In 1975, after years of advocacy that included the work of Ethel Jack and other Havasupai leaders, Congress returned 185,000 acres to the Havasupai tribe, according to NPS history. That later restoration sits in the file beside the earlier reduction to 518.6 acres and the removal of Billy Burrow from Ha'agio. Taken together, those entries do not describe a misunderstanding. They describe a long administrative sequence in which naming, mapping, employment, tourism, and land status work together to make a lived homeland appear secondary to the park that replaced it. The Grand Canyon remained in place. The official story about who belonged within it shifted much more than the rock ever did, where the river's history was quietly rewritten. The Colorado River is often described as the force that carved the Grand Canyon. Geological interpretation centers on the slow cutting of rock by a powerful current over millions of years. Visitors standing at overlooks typically hear that explanation in simple terms. What is rarely explained in equal detail is that the river, visible today, does not move through the canyon in the same way it once did. Since the mid-20th century, the Colorado River inside Grand Canyon National Park has been governed largely by the operation of a dam located upstream. The structure that changed the river stands at Glen Canyon, approximately 15 miles north of the park's eastern boundary. Glen Canyon Dam was completed by the U.S. Bureau of Reclamation in 1963, rising 710 feet above the Colorado River. The concrete arch dam created Lake Powell, one of the largest reservoirs in the United States. The reservoir can store roughly 24.3 million acre-feet of water when full. Water leaving the reservoir passes through turbines to generate hydroelectric power before continuing downstream through Marble Canyon and into the Grand Canyon itself. From the moment the dam began operating, the seasonal rhythm of the Colorado River changed. Instead of responding directly to snowmelt in the Rocky Mountains, river flow through the canyon began to follow the operational schedule of the power plant at the dam. Hydrological records maintained at Lee's Ferry show the magnitude of the shift. Before Glen Canyon Dam was built, spring snowmelt floods regularly produced flows above 80,000 cubic feet per second. Some historic floods exceeded 120,000 cubic feet per second. After the dam began regulating releases, daily flows usually ranged between about 8,000 and 25,000 cubic feet per second depending on electricity demand and reservoir management. Instead of a large seasonal flood followed by gradual decline, the river began rising and falling in smaller increments within a single day as turbines increased or reduced output. These operational changes affected more than the volume of water moving through the canyon. They altered how sediment traveled through the river corridor. Historically, the Colorado River carried enormous loads of silt and sand, eroded from upstream landscape. That material was transported through the canyon and deposited along banks, forming sandbars and beaches used today as campsites by river expeditions. When Lake Powell filled behind Glen Canyon Dam, much of that sediment settled to the bottom of the reservoir instead of continuing downstream. Water released from the dam therefore entered the canyon much clearer and carried far less suspended material. Researchers began documenting the consequences of this change within 2 decades of the dam's completion. Studies conducted by the U.S. Geological Survey during the 1970s and 1980s found that many sandbars along the Colorado River corridor were shrinking or disappearing. Early photographs from river expeditions taken in the 1920s and 1930s were compared with modern surveys. In several locations, wide beaches visible in early photographs had narrowed significantly by the late 20th century. The decline occurred because the river still eroded sandbars during high flows, but received much less sediment to rebuild them. Scientific attention to the problem increased in 1982 when the federal government established the Glen Canyon Environmental Studies Program. This research initiative examined how dam operations affected downstream ecosystems inside Grand Canyon National Park. Investigators measured river temperature, sediment transport, fish populations, and vegetation along hundreds of miles of river corridor. Their findings documented another important change caused by the dam: water temperature. Before Glen Canyon Dam existed, the Colorado River warmed during summer months as sunlight heated shallow flows moving through desert canyons. Measurements taken during early river expeditions indicate temperatures often exceeding 70 degrees Fahrenheit in late summer. After the dam began releasing water from deep within Lake Powell, the river entering the canyon remained much colder throughout the year. Typical release temperatures ranged between 46 and 50 degrees Fahrenheit. This colder river environment reshaped aquatic life in the canyon. Native fish species, such as the humpback chub, had evolved in a warmer, sediment-rich river. The colder water-favored species introduced for recreational fishing, including rainbow trout. By the early 1990s, biologists with the U.S. Fish and Wildlife Service were documenting declines in several native fish populations, while non-native trout expanded near Lee's Ferry and other reaches close to the dam. Federal agencies responded by forming the Glen Canyon Dam Adaptive Management Program in 1997. The program involved the Bureau of Reclamation, National Park Service, U.S. Geological Survey, tribal governments, and other stakeholders. Its purpose was to test whether controlled releases from the dam could partially restore natural river processes inside the Grand Canyon. These controlled releases became known as High Flow Experiment. A widely documented example occurred in March 2008. During that experiment, the Bureau of Reclamation released water from Glen Canyon Dam at approximately 41,500 cubic feet per second for 60 hours. Scientists coordinated the timing with sediment inflow from the Paria River, a tributary that occasionally delivers large pulses of sand during storms. The goal was to allow the temporary flood to redistribute this sediment and rebuild downstream sandbars. Researchers deployed sonar instruments, sediment samplers, and aerial photography to track the results. A U.S. Geological Survey report published after the experiment found that sandbars did increase in size at several locations during the artificial flood. However, subsequent monitoring also showed that many of these deposits gradually eroded again under normal dam operations. The river had briefly behaved like its earlier self, but only for a limited period. Hydrologists monitoring the Colorado River today describe the canyon's central waterway as a regulated river system. Daily flow patterns respond to power demand, reservoir levels, and water delivery obligations under the Colorado River Compact. Instruments installed along the corridor continuously record water temperature, discharge, and sediment concentration. These measurements are maintained by federal agencies and university researchers studying long-term ecological changes. Grand Canyon National Park still presents the river primarily through the language of geology and deep time. Interpretive materials emphasize that the canyon reveals nearly 2 billion years of Earth's history within its rock layers. That description is accurate for the surrounding cliffs and formations. The river running between those layers, however, now follows an operational schedule established in the 20th century. Reservoir management, hydropower generation, and environmental experiments determine its flow in ways that did not exist during earlier periods of canyon exploration. Technical records produced by federal agencies describe these adjustments in careful terms: discharge levels, sediment budgets, ecological monitoring, and adaptive management strategies. Taken together, those documents show how the Colorado River within the Grand Canyon became part of a controlled water system extending hundreds of miles beyond the park's boundaries, where a discovery was quietly retracted. Early exploration of the Grand Canyon occurred through a sequence of scientific expeditions, geological surveys, and river journeys that attempted to describe a landscape few outsiders had examined closely. One of the most influential figures in that process was geologist and explorer John Wesley Powell. Powell led the first well-documented river expedition through the canyon in 1869 and returned with a second expedition in 1871-1872 under the authority of the U.S. Geological Survey. His reports introduced the canyon to a wider scientific audience and helped establish the framework through which the canyon would be studied and eventually protected. Powell's surveys produced maps, stratigraphic observations, and detailed descriptions of the Colorado River corridor. The information gathered during those early expeditions was later expanded by federal survey teams and researchers studying the canyon's complex rock layers. Geological work continued into the early 20th century as scientists attempted to document the canyon's formations, mineral deposits, and structural features. These investigations were often published in technical bulletins or government reports, rather than widely circulated public accounts. In April 1909, a short newspaper article appeared in the Arizona Gazette describing a claim attributed to a Smithsonian researcher named G.E. Kincaid. The article stated that Kincaid had discovered a large cave complex within a side canyon of the Colorado River containing artifacts and rooms carved into rock walls. According to the newspaper story, the expedition had been supported by the Smithsonian Institution. The report suggested that the cave contained objects resembling tools, statues, and inscriptions that the article associated with an ancient culture. The location described in the article was said to lie somewhere along the canyon wall within the area now administered by Grand Canyon National Park. At the time the story was published, however, the canyon had not yet become a national park. Federal protection for the area existed only in the form of a national monument established in 1908 by President Theodore Roosevelt. The article provided several details about the reported discovery, including descriptions of carved chambers and storage rooms within a cavern system. It claimed the cave was located about 1,500 feet above the Colorado River and accessible only by descending steep canyon walls. The report also stated that the discovery had been kept quiet while further study took place. At the time, newspapers across the American Southwest frequently printed accounts of archaeological discoveries in the region, particularly following excavations at sites connected to ancient Puebloan cultures. Shortly after the article appeared, researchers and historians began examining the claim more carefully. The Smithsonian Institution later stated that it had no record of a researcher named G.E. Kincaid connected to such an expedition in the canyon. Smithsonian archives also did not contain documentation of an archaeological investigation matching the description printed in the newspaper. Without supporting records, the article remained isolated within newspaper archives rather than entering the established body of archaeological research conducted in the Grand Canyon region. Historians studying the case later pointed out that early 20th century newspapers sometimes published speculative reports or exaggerated accounts of archaeological discoveries. Such stories often reflected public fascination with ancient civilizations rather than confirmed scientific findings. The Arizona Gazette article appears to fall into that category, though it remains part of the historical record as a widely circulated report at the time of publication. The broader archaeological history of the canyon shows that documented research has followed different patterns. Scientific excavations conducted during the 20th century identified thousands of archaeological sites within the canyon and surrounding plateaus. According to the National Park Service, more than 4,000 known archaeological sites exist within Grand Canyon National Park boundaries. These sites include rock shelters, habitation areas, agricultural terraces, and storage structures associated with cultures such as the ancestral Puebloans, the Kohonina, and later native communities including the Havasupai and Hopi. Professional archaeological surveys conducted by the National Park Service and academic researchers rely on careful documentation, mapping, and excavation methods. Artifacts recovered from these sites are typically catalogued and stored in museum collections for study. Such investigations rarely resemble the large hidden chamber described in the 1909 newspaper article. Instead, most archaeological sites within the canyon consist of modest structures or cultural deposits that accumulated over centuries of human use. The difference between the newspaper report and later scientific work highlights how information about the canyon has often traveled through two separate channels. One channel consists of formal research reports produced by scientists and federal agencies. The other consists of scattered stories printed in newspapers or repeated in local lore. When the two sets of information conflict, historians usually rely on the documentation preserved in institutional archives and peer-reviewed research. Despite the lack of official records supporting the 1909 claim, the Arizona Gazette article continues to circulate in discussions about unexplained discoveries in the Grand Canyon. Researchers examining the story often focus on the absence of corroborating evidence in government archives. Without such documentation, the reported cave has not been recognized as a verified archaeological site within the canyon. Grand Canyon National Park continues to host archaeological research today under permits issued by the National Park Service. Investigators working in the canyon document sites using GPS mapping, photographic surveys, and controlled excavation techniques. The results of these studies are published in archaeological journals and park reports that become part of the permanent scientific record. Within that record, the canyon appears as a landscape shaped by both geological processes and long human occupation. The thousands of known archaeological sites identified by researchers illustrate that people have lived, traveled, and farmed within the canyon for many centuries. These discoveries have been documented through systematic study rather than isolated newspaper accounts. Stations that watch the sky. Along the south rim of the Grand Canyon, visitors usually notice the stone guardrails, the overlooks, and the slow movement of clouds across distant plateaus. Less visible are the instruments mounted on small towers or enclosed within modest weather shelters positioned near the rim. These devices measure particles in the air, changes in light scattering, and chemical traces carried by wind currents across the Colorado Plateau. Their work began quietly during the late 20th century, when scientists recognized that the canyon's immense distance views could function as a natural indicator of atmospheric pollution drifting across the American Southwest. Grand Canyon National Park became a central monitoring location after passage of amendments to the Clean Air Act in 1977. The amendments introduced protections for what were designated as Class I areas, landscapes considered nationally important for visibility and environmental integrity. The canyon was among the first places listed under this classification. Federal law required agencies to study and protect air clarity in such areas, particularly where industrial emissions might degrade scenic views. Atmospheric scientists working with the National Park Service began systematic monitoring soon after the legislation passed. Instruments installed at several rim locations measured fine particulate matter, sulfate particles, and nitrogen compounds suspended in the air. One of the primary stations was established near Hopi Point on the south rim, where the canyon opens widely toward distant plateaus. From that vantage point, visibility conditions can extend more than 100 miles on clear days. Researchers analyzing these measurements observed a pattern that differed from early assumptions. Pollution affecting the canyon's air did not originate mainly from nearby towns or tourism infrastructure. Instead, the majority of airborne particles arrived from distant sources hundreds of miles away. Winds circulating across Arizona, Utah, Nevada, and New Mexico transported emissions produced by power plants, smelters, and urban traffic into the canyon basin. Because the canyon's atmosphere is relatively isolated from local pollution sources, it provided scientists with a sensitive indicator of regional air quality trends. A major focus of investigation involved the Navajo Generating Station, which began operating in 1974. The facility stood on Navajo Nation land, roughly 135 miles northeast of the Grand Canyon's south rim. It consisted of 3 large coal-burning units, producing electricity for Arizona, Nevada, and California. Each unit released exhaust gases through a smokestack approximately 775 feet tall, allowing emissions to disperse widely across the surrounding plateau. By the early 1980s, atmospheric monitoring stations in the canyon had begun detecting elevated concentrations of sulfate particles associated with coal combustion. Scientists studying these particles trace many of them to sulfur dioxide released by the Navajo Generating Station. When sulfur dioxide enters the atmosphere, it reacts with oxygen and water vapor to form fine sulfate aerosols. These microscopic particles scatter sunlight, creating a bluish haze that reduces long-distance visibility. Federal regulators examined the connection between the power plant and haze in the canyon during a series of studies conducted through the late 1980s. Investigations coordinated by the Environmental Protection Agency concluded that emissions from the Navajo Generating Station contributed significantly to visibility impairment within Grand Canyon National Park. The findings were based on atmospheric modeling, chemical analysis of air samples, and wind trajectory studies tracing the path of airborne pollutants. In 1991, the Environmental Protection Agency issued a rule requiring the installation of advanced pollution controls at the power plant. The regulation mandated sulfur dioxide scrubbers capable of removing most sulfur compounds from exhaust gases before release into the atmosphere. These systems used limestone slurry to chemically bind sulfur dioxide, producing gypsum as a byproduct. Installation of the scrubbers occurred during the early 1990s, dramatically reducing emissions from the facility. Data collected from monitoring stations in the canyon showed measurable improvements following the installation of these controls. According to reports from the National Park Service Air Resources Division, sulfate concentrations in canyon air declined during the late 1990s and early 2000s. Visibility measurements improved as well. Average visual range across the canyon increased, allowing distant formations to appear more sharply defined during many observation periods. The canyon's atmospheric monitoring network eventually became part of the IMPROVE program, a nationwide system designed to track air quality conditions in national parks and wilderness areas. The program measures chemical composition of airborne particles, optical properties of the atmosphere, and meteorological conditions influencing pollutant transport. Data collected from Grand Canyon stations contribute to long-term records used by scientists studying regional air pollution. Monitoring revealed that haze in the canyon arises from several sources rather than a single emitter. Sulfate particles from coal combustion remain a significant contributor, but nitrate particles produced by vehicle emissions and agricultural activity also affect visibility. Wildfires in the western United States periodically add smoke particles to the atmosphere, temporarily reducing visibility across large regions, including the canyon. The Navajo Generating Station continued operating for decades after installation of pollution controls. During that period, it remained one of the largest power plants in the American Southwest, supplying electricity and water pumping power to multiple states. Economic conditions eventually changed the plant's role. Declining demand for coal-fired electricity and competition from natural gas generation led to its closure in 2019. Throughout the plant's operating history, atmospheric instruments along the Grand Canyon rim continued measuring airborne particles hour by hour. The equipment recorded seasonal patterns, wind-driven pollution events, and gradual improvements following regulatory changes. These measurements created one of the longest continuous environmental datasets associated with any national park landscape. Visitors standing at canyon overlooks today may notice subtle variations in the clarity of distant cliffs and mesas. Some days reveal sharp outlines across the entire horizon, while others show a faint haze softening the distant view. These conditions are recorded continuously by monitoring devices positioned quietly near the rim. Their data show how air moving across the canyon carries chemical traces of industrial activity occurring far beyond park boundaries, ground that was quietly removed from the map. Administrative boundaries surrounding the Grand Canyon appear stable on modern maps. The park covers more than 1 million acres across northern Arizona and is commonly presented as a single continuous protected landscape. That impression comes from the familiar outlines printed on visitor guides and federal land maps. Earlier records show a more complicated arrangement. For several decades after the park was established in 1919, sections of land within or immediately adjacent to the canyon were withdrawn, surveyed, or reassigned through a series of federal administrative decisions that rarely appeared in public park interpretation. Much of this activity centered on mineral deposits embedded within the canyon's surrounding plateaus. Geological surveys conducted in the early 20th century identified numerous breccia pipe formations scattered across northern Arizona. These vertical structures formed when underground caverns collapsed and filled with broken rock fragments. Some breccia pipes contained concentrated uranium ore. By the 1940s and 1950s, federal agencies began evaluating these formations as potential sources of uranium during the early years of the American nuclear program. Exploration expanded rapidly after the discovery of high-grade uranium deposits across the Colorado Plateau. Mining companies and federal survey teams mapped dozens of potential sites near the Grand Canyon's northern and southern rims. Although the national park itself restricted most new mining activity within its boundaries, claims were still permitted on surrounding federal lands managed by the Bureau of Land Management and the U.S. Forest Service. As a result, geological exploration often occurred only a few miles from major canyon viewpoints. The most closely documented example is the Canyon Mine site, located in the Kaibab National Forest, about 6 miles south of the south rim of Grand Canyon National Park. The mine sits within a breccia pipe formation discovered during uranium exploration in the late 20th century. Geological surveys identified ore grades high enough to justify development, and a mining company began constructing an underground shaft during the early 1980s. Operations at Canyon Mine proceeded intermittently over the following decades due to regulatory challenges and fluctuating uranium prices. The site gained national attention during the 2010s as federal agencies reconsidered uranium mining across lands surrounding the Grand Canyon. Environmental groups, tribal governments, and scientists raised concerns about possible contamination of groundwater, feeding springs, and aquifers connected to the canyon. One of the central scientific investigations related to this concern focused on groundwater movement through the region's complex rock layers. The U.S. Geological Survey and the National Park Service began monitoring water chemistry at springs located inside the canyon. Researchers collected samples from locations such as Horn Creek, Garden Creek, and other perennial water sources emerging from canyon walls. Their objective was to determine whether uranium mining activity outside the park could influence water quality inside the canyon itself. The Canyon Mine case became particularly significant because of its proximity to Red Butte, a site considered sacred by the Havasupai tribe. Tribal leaders argued that the mine threatened both cultural landscapes and groundwater resources. Legal challenges and regulatory reviews followed. In 2012, the United States Department of the Interior issued a 20-year withdrawal preventing new mining claims on more than 1 million acres of federal land surrounding the Grand Canyon. However, previously approved projects with valid existing rights were allowed to continue operating under federal law. Because Canyon Mine had been permitted before the withdrawal, the project remained legally active. Development resumed after additional environmental reviews, and the mine shaft reached a depth of roughly 1,400 feet. According to reports from the USS Forest Service and the Arizona Department of Environmental Quality, uranium ore extraction began in 2024 under updated regulatory oversight. The site illustrates how mineral exploration and national park protection have overlapped across the Grand Canyon region for decades. Although the park boundary restricts most mining within the canyon itself, geological formations containing uranium extend across a much larger area of the Colorado Plateau. Administrative boundaries do not follow the distribution of these formations. As a result, mining claims have historically appeared near the park's edges, even while the canyon interior remained protected. Scientific monitoring continues around the Canyon Mine site. Researchers measure groundwater chemistry, radionuclide concentrations, and trace metals in springs located both near the mine and inside the canyon. Early monitoring reports have not detected widespread contamination associated with the site, though studies remain ongoing. Federal agencies maintain observation programs designed to detect any long-term changes in water quality that could affect ecosystems within the canyon. These investigations involve cooperation between several agencies, including the National Park Service, the U.S. Geological Survey, and the U.S. Forest Service. Monitoring equipment records groundwater chemistry at multiple sites across the plateau and canyon walls. Data collected from these instruments contributes to long-term environmental assessments, evaluating the potential impact of uranium mining near the park. The Canyon Mine example illustrates how administrative decisions surrounding the Grand Canyon have extended beyond the park boundary itself. Land withdrawals, mineral rights, and environmental monitoring programs shape the region's management in ways not immediately visible on visitor maps. Federal land records describe a landscape where conservation policies coexist with mineral exploration rights established under earlier laws. Visitors standing along the south rim typically see only the canyon's cliffs and distant mesas stretching toward the horizon. Beneath that view lies a larger administrative landscape defined by mineral surveys, land withdrawals, and regulatory oversight extending across millions of acres of surrounding plateau. Geological formations containing uranium remain scattered across that plateau, intersecting with federal land management policies that date back more than a century. Records that remained in federal files. Large areas of the Grand Canyon appear quiet in official visitor materials. The park is usually presented through overlooks, trails, geological interpretation, and archaeological history. Yet another layer of activity has taken place within the canyon through scientific research permits issued by federal agencies. Many of these studies involve access to remote areas not reached by visitors. Their purpose ranges from wildlife monitoring to geological sampling and atmospheric observation. Some of the work occurs in locations closed to the public for safety or preservation reasons. The documentation describing these activities is often found in research archives rather than in the interpretive material provided to visitors. The National Park Service maintains a formal research permit and reporting system that regulates scientific work within national parks. Investigators must submit detailed proposals before conducting fieldwork. These proposals describe the methods used, equipment deployed, and locations accessed during the study. Once approved, the researchers are allowed to enter areas that are otherwise restricted to visitors. These areas can include remote caves, fragile archaeological sites, and sections of canyon terrain where human presence must be carefully controlled. One category of research that has attracted attention in the Grand Canyon involves cave systems located in the canyon walls and surrounding plateau. Thousands of caves exist within the park's limestone and sandstone formations. Many of these caves remain largely unexplored due to difficult access and environmental sensitivity. Park managers regulate entry to protect fragile mineral formations and archaeological deposits that may be present inside the caves. Among the most documented cases involving restricted cave research is the investigation of Grand Canyon Cave of the Domes, an extensive subterranean formation discovered during early geological surveys in the 20th century. The cave contains large chambers formed through the dissolution of limestone by groundwater over long periods of time. Its interior includes mineral formations such as stalactites and flowstone deposits rarely found in the drier sandstone portions of the canyon. Because of the cave's fragile formations, access to the site has been tightly controlled by the National Park Service. Entry typically requires scientific permits and specialized climbing equipment due to the cave's vertical passages and narrow entrances. Researchers studying the cave have focused on mineral growth patterns, microclimates, and biological communities adapted to the cave environment. One of the most significant scientific investigations related to this cave system occurred during the late 20th century when geologists began examining mineral deposits inside several Grand Canyon caves to determine their age. These deposits, known as speleothems, form slowly as mineral-rich water drips through cave ceilings. By analyzing the isotopic composition of these formations, scientists can reconstruct climate conditions extending far into the past. Researchers working with the U.S. Geological Survey collected speleothem samples from caves within the Grand Canyon region during the 1990s and early 2000s. Laboratory analysis of these samples revealed records of past climate cycles preserved in mineral layers. Some formations recorded fluctuations in rainfall and temperature dating back more than 500,000 years. The research showed that cave deposits inside the canyon contain long-term environmental records comparable to those found in polar ice cores or ocean sediments. These mineral layers accumulate gradually as groundwater dissolves limestone and redeposits calcium carbonate inside cave chambers. Variations in isotopic ratios within the layers reflect changes in precipitation patterns across the Colorado Plateau. Because of the scientific importance of these formations, the National Park Service restricts public access to most caves within the park. Unauthorized entry can damage delicate mineral structures that require thousands of years to form. In addition, caves may contain archaeological artifacts, animal remains, or ancient plant material preserved in dry environment. For these reasons, cave locations are often omitted from public maps. Federal cave management policy within the park also reflects legislation passed at the national level. The Federal Cave Resources Protection Act was enacted in 1988 to safeguard cave systems on federal lands. The law allows agencies to keep cave locations confidential if disclosure could lead to damage or vandalism. As a result, detailed maps of caves within the Grand Canyon are generally restricted to researchers and park officials. Scientific work conducted under these protections has revealed that the canyon's cave environments host specialized ecosystems. Biologists have documented species of insects, spiders, and microorganisms adapted to the darkness and stable temperatures of subterranean chambers. These organisms often exist nowhere else outside the cave systems where they evolve. Geological studies continue to expand knowledge of these underground landscapes. Researchers have mapped passages extending through limestone formations beneath sections of the canyon rim and plateau. Some caves contain vertical shafts reaching hundreds of feet below the surface. Others consist of narrow passages winding through rock layers formed hundreds of millions of years ago when the region was covered by shallow seas. The documentation produced by these research efforts remains largely technical in nature. Scientific papers describing cave mineral analysis, microclimate measurements, and biological surveys are published in specialized journals or archived in park research databases. Although the canyon's surface landscapes are widely known, the subterranean environments beneath them remain comparatively unfamiliar to the general public. These caves illustrate another dimension of the Grand Canyon landscape that exists beyond the visible cliffs and river corridors. Beneath the rock layers exposed along the canyon walls lies a network of underground chambers formed through geological processes that continue today. Access to many of these locations is limited to scientific investigations conducted under federal research permits, under orders that closed the rim. Closure in the Grand Canyon is usually described in practical language. A trail is unsafe. A road is under repair. A facility cannot operate. The terms are administrative and narrow. They do not often suggest how much of the park can disappear from public use at once when infrastructure, weather, and fire overlap in the same corridor. The legal mechanism is straightforward. Under the superintendent's compendium, areas can be closed or restricted for public safety, resource protection, emergency operations, or administrative need, and those closures do not apply in the same way to official use. That difference matters because it creates two simultaneous versions of the canyon during an emergency, one for the public and one for crews, investigators, and park staff moving through controlled ground. The most instructive recent case began on the North Rim in July 2025. Grand Canyon National Park announced on July 10 that the North Rim was closed to all visitors because of the White Sage Fire and evacuation orders near Jacob Lake. In the same notice, the park stated that a separate lightning-caused fire, the Dragon Bravo Fire, was already being managed on the North Rim south of the basin. Within 3 days, the fire picture changed from a remote incident to a park-wide access problem. On July 13, the park reported active suppression efforts, strong wind gusts, low humidity, and retardant drops in the Roaring Springs drainage, an area tied directly to the canyon's water supply system. That geography is more important than it first appears. Roaring Springs is not just a named location in the inner canyon. It is the source area for the Trans-Canyon Waterline, the long pipeline that carries water to Phantom Ranch, inner canyon facilities, and both rims. The park's project pages describe the line as roughly 12.5 miles long, much of it running through steep and difficult terrain along the North Kaibab Trail corridor. When a fire moves through that drainage, the issue is no longer confined to trees, understory, and trail tread. It extends to pumps, treatment systems, buried and exposed pipe, employee housing, campgrounds, mule operations, and the ordinary ability of the park to keep water moving between elevations. The well-documented case at the center of this closure history is the Dragon Bravo Fire and the chain of access restrictions that followed it. On the 13th of July, 2025, the park closed multiple South Rim corridor routes because of safety concerns linked to the fire. Later park notices stated that Bright Angel Trail, South Kaibab Trail, the Tonto Trail segment between Tip-Off and Havasupai Gardens, Phantom Ranch, Bright Angel Campground, and the Phantom Ranch Canteen area were all affected at different stages. The lower part of the canyon, which visitors often treat as stable once a reservation or permit has been secured, became contingent on conditions created by a fire burning far above it on the North Rim and in the Roaring Springs corridor. A second event on the same date made the closures more extensive. The park announced on July 13 that the North Rim water treatment facility had caught fire and that chlorine gas was released from the site. Firefighters reported the problem while responding to the Dragon Bravo fire. That detail changed the character of the closure from a standard wildfire perimeter to a mixed hazard zone involving both fire behavior and industrial chemical risk. Public access could not be treated as a matter of scenic inconvenience or ordinary rerouting. It became part of a controlled emergency landscape where suppression, hazardous materials response, water utility damage, and evacuation were unfolding together. The closure pattern that followed was broad and uneven rather than absolute. The North Rim status page later showed a long list of areas still closed because of the Dragon Bravo fire and subsequent stabilization work, including the North Kaibab Trail north of the Ribbon Falls Junction, the Arizona Trail through the park, Woodfus Trail, Transept Trail, Bridle Path, Cape Royal Trail, Cape Final Trail, Cliff Spring Trail, Roosevelt Point Trail, and other North Rim routes. By contrast, the 30th of September 2025 announcement described a partial reopening beginning October 1, with daytime access restored to selected points such as Point Imperial and Cape Royal Road areas. The park's phrasing was careful. Reopening was phased, limited, and dependent on continued assessment. Access did not return in a single moment because the canyon was not being managed as one unitary space. Different sectors reopened according to road condition, hazard trees, utility status, trail damage, and staffing capacity. The official language used for later updates is also revealing. In the North Rim status notice for the 2026 season, Superintendent Ed Keeble said, "We will open what we can, where we can, when we can." The sentence is concise and operational. It also reflects how closures function in the Grand Canyon. They are not merely yes or no declaration. They are an ongoing sorting process in which roads, trails, viewpoints, water systems, and overnight areas are separated into categories of readiness. The public map may continue to show a familiar park outline, but usable ground is redefined by internal assessments that can change weekly or daily. One reason those internal assessments matter so much is that the inner canyon depends on narrow corridors. The park's hiking alerts and project updates after the 2025 fire repeatedly pointed to the same structural reality. A small number of bridges, trails, pump facilities, and trail-adjacent construction zones carry an unusually large share of visitor movement and park operations. After rockfalls in August 2025 caused a 50-foot section of river trail to collapse, the park kept River Trail and Silver Bridge closed while rebuilding plans and additional assessments proceeded. That was not simply a trail closure. It altered how people could move between Bright Angel, Phantom Ranch, and the South Kaibab system. In a canyon organized around limited crossing points, a single failure can redraw the usable map. What makes this case distinct is not secrecy in the literal sense. The park issued news releases, status pages, and closure notices throughout the event. The deeper issue is that the public image of the Grand Canyon still favors permanence, stone, depth, age, and open vistas. The administrative record shows something more conditional. Access depends on a thin set of modern systems placed inside difficult terrain, and when one of those systems fails under stress, large sections of the park can be closed while official use continues under different rules. The compendium states that closures may not apply to official or administrative use, and the 2025 fire season showed exactly what that means in practice. Visitors saw locked roads, closed trails, and suspended overnight use. Crews saw water infrastructure, chemical hazards, fire lines, post-fire erosion risk, and damaged transport corridors. By February 2026, the park reopened the lower North Kaibab Trail to Manzanita Rest Area and later to Cottonwood Campground, while keeping the trail north of Ribbon Falls closed for continued post-fire evaluation and maintenance. The park's notices did not describe the canyon as restored. They described segments, thresholds, and conditions. That is how closure appears in the official file, not as a rare interruption, but as a routine management tool for a landscape that depends on infrastructure far more fragile than its public image suggests. The archive that slowly changed the story. Grand Canyon National Park appears in public interpretation as a landscape defined by geology, tourism, and preservation. Official brochures describe layered rock formations, the Colorado River, and a long timeline of natural processes shaping the canyon. Federal management files contain another category of records that rarely appear in visitor material. These records consist of administrative reports, investigative documents, and internal communications that become public only years after events occur. Their release often changes how certain incidents inside the canyon are understood. One of the most documented examples involves a mid-air collision that occurred above the canyon during the summer of 1956. At the time, commercial aviation was expanding rapidly across the United States. Aircraft routinely flew through uncontrolled airspace, where pilots relied primarily on visual separation from other planes. The airspace above the Grand Canyon became a popular scenic route used by airlines operating transcontinental flights between the West Coast and the Midwest. On the 30th of June 1956, two aircraft approached the canyon from different directions at cruising altitude. One was a Douglas DC-7, operated by Trans World Airlines, carrying 70 passengers and crew. The other was a Lockheed L-1049 Super Constellation, operated by United Airlines with 58 people on board. Both aircraft departed from Los Angeles within minutes of each other and were scheduled to continue eastward across Arizona. At approximately 21,000 feet above the canyon, the aircraft collided in clear weather conditions. Wreckage from both planes scattered across steep terrain within the eastern section of the canyon near the confluence of the Colorado and Little Colorado rivers. The accident killed all 128 people aboard the two aircraft. At the time, it was the deadliest aviation disaster in the world. Rescue operations began shortly afterward, but were severely limited by the canyon's terrain. Park rangers and search teams reached portions of the wreckage on foot and by helicopter during the following days. The crash site was located in an area difficult to access even under normal conditions. Investigators from the Civil Aeronautics Board documented the location of debris fields spread across cliffs and slopes deep within the canyon. The Civil Aeronautics Board investigation determined that both aircraft had deviated slightly from their assigned routes to give passengers a better view of the canyon landscape. This practice was common during that era because air traffic control coverage across the western United States was incomplete. Pilots could request clearance to operate temporarily outside their standard flight corridors when weather conditions permitted. Investigators concluded that the collision occurred because the two aircraft were operating under visual flight rules in uncontrolled airspace. Each crew expected to maintain separation by visually detecting other aircraft. When both planes entered the same portion of sky at similar altitude, the time available for avoidance was extremely limited. The accident prompted a major reorganization of the American aviation system. In the months following the crash, federal authorities reviewed how airspace was managed across the country. Congressional hearings examined the limitations of the existing system, which relied on a patchwork of civilian and military radar coverage and inconsistent communication procedures. One outcome of those hearings was the creation of a unified federal aviation authority responsible for managing the nation's airspace. In 1958, Congress passed legislation establishing the Federal Aviation Agency, later renamed the Federal Aviation Administration. The agency introduced new air traffic control procedures, expanded radar coverage, and created positive control airspace where aircraft separation would be maintained by controllers rather than by visual observation alone. Changes were implemented across the United States during the following decade. Radar systems were installed along major air corridors, and flight routes were reorganized to prevent aircraft from occupying the same altitude in busy areas. The airspace above the Grand Canyon was also redesigned. Controlled flight corridors were introduced to separate commercial aircraft from sightseeing traffic operating at lower altitudes. Today, the canyon is surrounded by a complex airspace structure designed specifically to prevent a recurrence of such accidents. Special flight rules areas regulate aircraft routes above the park. Tour flights operate within designated corridors and altitude restrictions that keep them separated from other aircraft passing through the region. The crash sites themselves remain within the canyon landscape. Portions of the wreckage from the 1956 collision were left in place because removing them from the steep terrain was considered impractical. Some fragments remain scattered across remote slopes, where investigators first documented them during the original search operations. Records from the Civil Aeronautics Board investigation remain part of the Federal Archive, documenting the event. These documents include radar data, witness reports, wreckage analysis, and communications between aviation authorities following the accident. They provide a detailed reconstruction of the circumstances that led to the collision and the regulatory changes that followed. The Grand Canyon continues to attract millions of visitors each year who view the landscape from rim overlooks, river corridors, and aircraft flying within regulated sightseeing routes. Above the canyon walls, aircraft now move through carefully structured airspace managed by radar systems and air traffic controllers located hundreds of miles away. The administrative files connected to the 1956 collision illustrate how a single event within the canyon's airspace produced lasting changes in national aviation policy. Geological formations within the canyon record natural processes spanning hundreds of millions of years. Aviation records associated with the canyon document a different kind of timeline, one measured in regulatory reforms, technical upgrades, and procedural adjustments made in response to events that occurred high above the canyon walls. If you found this video interesting, consider subscribing for more videos like this one. Leave a comment with your thoughts and let us know which mystery we should investigate next. Thanks for watching, and we'll see you in the next video.